What are metaclasses in Python? What are metaclasses? What are they used for?
Note, this answer is for python-2.x as it was written in 2008. Metaclasses are slightly different in 3.x. Metaclasses are the secret sauce that make class work. The default metaclass for a new style object is called type. Metaclasses take 3 args: name, bases, and dict. Here is where the secret starts. Look for where name, bases, and the dict come from in this example class definition. Let's define a metaclass that will demonstrate how class calls it. And now, an example that actually means something. This will automatically make the variables in the list attributes set on the class and set to none. Note that the magic behavior that initialized gains by having the metaclass init_attributes is not passed onto a subclass of initialized. Here is an even more concrete example showing how you can subclass type to make a metaclass that performs an action when the class is created. This is quite tricky.
One use for metaclasses is adding new properties and methods to an instance automatically. For example, if you look at Django models, their definition looks a bit confusing. It looks as if you are only defining class properties. However, at runtime the person objects are filled with all sorts of useful methods. See the source for some amazing metaclassery.
A metaclass is the class of a class. A class defines how an instance of the class, i.e. an object, behaves, while a metaclass defines how a class behaves. A class is an instance of a metaclass. While in Python you can use arbitrary callables for metaclasses, like Jarib shows, the better approach is to make it an actual class itself. Type is the usual metaclass in Python. Type is itself a class, and it is its own type. You won't be able to recreate something like type purely in Python, but Python cheats a little. To create your own metaclass in Python you really just want a subclass type. A metaclass is most commonly used as a class factory. When you create an object by calling the class, Python creates a new class when it executes the class statement by calling the metaclass. Combined with the normal __init__ and __new__ methods, metaclasses therefore allow you to do extra things when creating a class, like registering the new class with some registry or replace the class with something else entirely. When the class statement is executed, Python first executes the body of the class statement as a normal block of code. The resulting namespace, a dict, holds the attributes of the class to be. The metaclass is determined by looking at the base classes of the class to be. Metaclasses are inherited at the __metaclass__ attribute of the class to be, if any, or the __metaclass__ global variable. The metaclass is then called with the name, bases, and attributes of the class to instantiate it. However, metaclasses actually define the type of a class, not just a factory for it, so you can do much more with them. You can, for instance, define normal methods on the metaclass. These metaclass methods are like class methods in that they can be called on the class without an instance, but they are also not like class methods in that they cannot be called on an instance of the class. Type.__subclasses__ is an example of a method on the type metaclass. You can also define the normal magic methods like __add__, __iter__, and __get__ to implement or change how the class behaves. Here's an aggregated example of the bits and pieces.
Others have explained how metaclasses work and how they fit into the Python type system. Here's an example of what they can be used for. In a testing framework I wrote, I wanted to keep track of the order in which classes were defined, so that I could later instantiate them in this order. I found it easiest to do this using a metaclass. Anything that's a subclass of my type then gets a class attribute underscore order that records the order in which the classes were defined.
If you want to support the channel, please consider liking and subscribing.